Good morning, students. In today's lesson, we are going to learn about organic chemistry. Now, what is organic chemistry? Organic chemistry is the chemistry of the compounds of carbon, or in other words, it's the chemistry of carbon compounds. So if you look at chemistry, there are different branches such as physical chemistry, inorganic chemistry, and organic chemistry. Okay, so inorganic chemistry is what you learned in the chapters before about sulfuric acid, ammonia, production of metals, and so on. So that would be inorganic chemistry. Inorganic chemistry, okay, in organic chemistry, we learn about the chemistry of the carbon compounds. So we will be learning units 10.1, 10.2, and 10.5 for the CT1 exam. So 10.3 and 4 I will be doing later because 10.2 and 10.5 they are connected. So I merged them together. Okay. So let's look at what organic compounds are. Chemical compounds are grouped into two big categories, which are organic compounds and inorganic compounds. Okay, and organic compounds can be found naturally. A lot of compounds that are present in living things are found to have carbon. Okay, and so they are known as organic compounds. Now, organic compounds can also be synthesized. That means they can also be man-made. However, all organic compounds contain carbon and a few other elements. Okay, so carbon is the main element in organic compounds. And there are far more organic compounds than inorganic compounds. Okay, so let's see why there are so many organic compounds. These are some examples of organic compounds: fuels, fossil fuels, and petrol, diesel that we get from the fossil fuels. These are organic compounds. Carbohydrates, fats, proteins, you find them in food. We need them for our good health. So these are organic compounds. Vitamins are organic compound. Penicillin, which is an antibiotic, is an organic compound. Plastics. So we can see that everywhere we turn around, we have plastics, our face mask, our stationery items, our clothing, all these are synthetic fibers. Okay, so cotton, silk, wool, these are also organic compounds. Rubber, the DNA that we have in our cells. Aspirin, which is a painkiller, all these are organic compounds. Okay, so we can say that organic chemistry is a part of everyday life. So when you look around us, you see there's a lot of organic compounds without even us realizing it. Okay, so let us see why there are so many carbon compounds. What is so great about this carbon element, that it has got so many compounds, so much so that one branch of chemistry is dedicated to this carbon compounds. Okay, it looks like this carbon is a very friendly element. Now, carbon forms covalent bonds. Okay, so we know that covalent bonds are formed by the sharing of electrons. Okay, carbon forms 4 covalent bonds. It's in group 4 of the periodic table, so it has a valency of 4. Now, carbon can form carbon to carbon single bond, carbon to carbon double bond, or carbon to carbon triple bond. Okay, so this is a single bond, this is a carbon to carbon double bond, and this is a carbon to carbon triple bond. Okay, now to form one bond, you need 2 electrons. Okay, so remember, to form a single bond, 2 electrons are needed. So if it is a double bond, 4 electrons will be involved, and so on. Okay, now besides that, carbon can also form long chain compounds, and carbon can also form ring chain compounds. Okay, so many carbon atoms, they can join together to form a long chain compound. So these will be attached to other carbon or other atoms. Okay, carbon can also form ring structures like this. So here these will be the carbon atoms attached to other atoms. So because of this ability of forming single bond, double bond, and triple bond, and because carbon can form long chain compounds and carbon can also form ring chain compounds, there are so many carbon compounds. Okay, it can form compounds in many different ways. Okay. Right, so these are some more examples for you to see how the bond formation is done. So look at this. This is single bond. You can see the carbon to carbon single bond. Here you can see the carbon to carbon double bond. And as I said earlier, carbon has 4 bonds. So you can see each carbon atom is surrounded by different atoms. So if this is a double bond, the 2 bonds here, and this is another bond, third one, and this is the 4th one. Okay, so triple bond. Now these are examples to show how carbon can form ring-like structures. Okay, so now let's move on to the next one, homologous series. So when you look at organic chemistry, the introductory part, you will see that there are quite a few terms for you to know. So once you are familiar with these terms, then later on the rest of the organic chemistry will be quite easy for you. Okay, so homologous series. Now here we learned earlier that there are a lot of millions and millions of organic compounds. Okay, and to study their properties, what chemists have done is they have placed compounds with similar properties in groups or families. Okay, compounds with similar properties in groups or families, which is called a homologous series. Okay, so for example, if you have year 11, if you have to put all this year 11 in one class and just teach them, then it would not be, it's not reasonable, isn't it? So you have different classes. So 11, 1, you study a certain set of subjects. So if you look at 11, 5, they have a set of subjects. Okay, so these are kind of classifications. So the organic compounds have been put into groups in families called homologous series. Okay, so for your syllabus, you will learn about 4 to 5 homologous series. All right, so let's see what the homologous series is all about. Now, characteristics of homologous series. A homologous series is a group of organic molecules with similar chemical properties. Okay, so the chemical properties are similar. Chemical properties means combustion, reacting with other elements, and so on. Okay, so they have similar chemical properties. Each series has a general formula. Okay, so just like each class, each of you have your own class. So you can say each group has a own general formula. So every homologous series will have its own general formula. Now, each successive compound will differ from the one before it by a CH2 group. Okay, so CH2 is not a compound, it's a group of atoms only. Okay, so let me show you. For example, if these are the molecular formula: C2H6, C3H8. So what you can see is in the homologous series, you will find that the neighboring molecule, okay, the one that is just after that, there'll be a difference of 1 carbon atom and 2 hydrogen atoms. So the next one you see 1 carbon atom plus 1 carbon, it becomes C2. The following one plus another carbon, it becomes C3. So here hydrogen plus 4 plus 2, 6, 6 plus 2, 8. Okay, so this is also a characteristic of the homologous series. Now, when you look at the physical properties, they change in a regular way. Okay, so that means the properties are not like haphazard. So you will find that the first few in a homologous series, the first few compounds are gases. Then they slowly become liquids. And then after that, they are solids. Okay, it is not like, one is a solid, the next one is a liquid, and then it's a solid again. Then it's not like that. So the physical properties change in a regular way. All right. So the homologous series, they have similar chemical properties because they have the same functional group. All right. So these functional group general formula, I will give examples later when we go into when we study in detail about the homologous series. But for now, you know that a homologous series is a group of organic molecules which have similar chemical properties. They have same general formula and same functional group. Okay, the physical properties change in a regular way, and each member, the neighboring molecules, okay, and the neighboring molecules differ by a CH2 group. So these are the characteristics of the homologous series. Right? Okay, so now we move on to the next term, which is hydrocarbon. Now we can say that hydrocarbons are the simplest organic compounds because the hydrocarbons, they contain only carbon and hydrogen. Okay, so carbon on its own is just an element. Only when it reacts with another element, it can form a compound. So here it's only carbon and hydrogen. From the name itself, you can identify hydro is for the hydrogen and carbon for the carbon itself. Okay, so hydrocarbons are the simplest organic compounds because they're made up of only hydrogen and carbon. Okay, and the hydrocarbons are classified based on their structure. So they are classified as alkanes, alkenes, alkynes. So for your syllabus for year 11, you only learn about alkanes and alkenes. Okay, all right. Now, in organic chemistry, the structure of a molecule is very important. Okay, previously when we learned about inorganic compounds like sulfuric acid and sodium carbonate, we focus more on the chemical formula. But here in organic chemistry, the structure is also very important. So based on structure, hydrocarbons are classified into alkanes, alkenes, alkynes. Okay, so to give you an idea, basically it is like this: organic compounds, and then you have the hydrocarbons, and then you have the non-hydrocarbons. Okay, all elements can't be only carbon and hydrogen. So under hydrocarbons, you have alkanes, alkenes. Now non-hydrocarbons you will learn later. So examples can be alcohols. All right, so this is more or less the organization, you know, how the classification is. All right, so let's move on to alkenes. So alkenes, as we saw just now, they are hydrocarbons and they contain only single bonds. Okay, so I told you earlier that structure is very important in organic chemistry. So all of these alkanes, they only have single bonds. In that way, they are very simple. They only have carbon and hydrogen, and they also have only single bonds. Okay, so each carbon atom forms a single bond with 4 other atoms. Okay, so every time you can see in an alkane, one carbon will be attached to 4 other hydrogen atoms. Okay, so every time there will be 4 other atoms. Sorry, not 4 other hydrogen atoms. There'll be 4 other atoms. So the 4 atoms can be hydrogen atoms, or they can also be carbon and hydrogen atoms. Is that clear? Okay, so each carbon atom forms a single bond with 4 other atoms. So in this case, you can see the carbon, 4 bonds attached to the hydrogen. But later on, you will see the examples where carbon forms a single bond with another carbon as well. Okay, so let me show you one more example. So here, okay, so here you see the carbon forms 4 bonds with 4 hydrogen atoms. Here it forms 4 bonds, but 3 bonds are with hydrogen, another one with the next carbon. But whatever it is, each carbon must have 4 single bonds. Okay, so this is for alkanes. All right. Now, because alkanes contain only single bonds, they are called saturated hydrocarbons. Okay, the 4 bonds of carbon are attached to 4 other elements, so that there is no more bond left to react. So alkanes are called saturated hydrocarbons. All right. So now let's move on to the naming of the alkanes. Okay. For example, let us say you are 11-5 students. You don't all have the name 11-5, 11-5, right? So 11-5 is something like the alkane homologous series. Each of you have your own name. So the same way, each member has its own name. But the thing here is this, the naming is quite easy because all alkanes, they end with ANE. So you see here, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane. All right. Only the first part changes. Only the prefix changes. Okay. So in English, you must have learned about prefix. Okay. The first part of the word. So here the prefix will change. And let us see how the prefix changes or why it changes. Okay. Now, these are the prefixes for the first 10 carbon atoms. Right, so you learn it once, you will use it throughout your organic chemistry. Okay, so let's see how it works. Now, when a compound contains 1 carbon atom, it's called its meth. So, like for example, since it's an alkane, it's methane. If it is an alcohol, it will become methanol. Okay, is that clear? That is how it works. If it is an acid, then it becomes methanoic acid. So the prefix meth refers to the compound having 1 carbon atom. 2 carbon atoms is eth, 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 is hept, 8 carbon atoms oct, 9 carbon atoms non, and 10 carbon atoms dec. Okay, so when you look at 5 carbon atoms, it is something similar to what you learn in maths, isn't it? In maths, you see, you have a 5-sided figure. What do you call that? It's a pentagon. Okay, so here it is it's an alkane, so pentane. So you also must have come across hexagon, heptagon, right? So the prefix refers to the number. Okay, all right. So in order for you to remember this easily, there is a memory aid. You can use this. So if you look at the first one, this is for all the 10 alkanes. Okay, many equestrian people buy pretty handsome horses of noble descent. All right. Okay, if this is too long for you, you should know at least for the you should know at least for the first 4. All right, so first 4, the shorter one, monkeys eat peanut butter. So the M here stands for, M will be for the methane, then ethane, propane, butane. So 5 carbon pentane, okay, because it's related to the figure, so I think you can keep it in mind. Pentane, hexane. Either you remember this one or the first one. It's up to you, whichever you want to use, or you just want to sit down and revise for a few times and then you want to remember, that's fine. Okay, so the most important thing is that you remember the names of the alkanes. All right, so so that is why the first alkane is methane, the second ethane, propane, butane, pentane, hexane, and so on. Is that clear, student? So this is how the alkanes are named. Now, let us look at the molecular formula. So we learned the names of the alkane. So alkanes are chemical compounds. So obviously they will have a formula. So every molecule will have every compound will have its own formula. Okay, so if you look at alkanes, as I told you earlier, if you look at alkanes as your alkane homologous series as a certain class, every student has you have your own name, isn't it? Your own name. So here the molecules have their name, so they also should have a molecular formula. But the thing is, you don't have to sit down and learn the molecular formula for each and every compound. That would take a lot of time. So what you can do is you just have to use the general formula. Okay, so we are learning about the alkane homologous series, and the general formula for alkane is CnH2n plus 2, where N stands for the number of carbon atoms. Okay, so once you know the number of carbon atoms, it is easy for you to, it will be easy for you to write the molecular formula. Okay, so once again, the general formula of alkane is CnH2n plus 2. So let's see how you can calculate the molecular formula by using the general formula. Okay, so let me use the whiteboard to show you this. Yeah, I hope everyone is able to see the whiteboard. Okay, general formula of alkane is CnH2n plus 2. N stands for the number of carbon atom. So first let's find the molecular formula for methane. So for methane, N is equal to 1. So C, N is 1, H, 2 times 1 plus 2. So that would be C, 2 times 1, 2, 2 plus 2, 4, CH4. Okay, now ethane, N is equal to 2. So C2, H2 times 2 plus 2 is C2H, 2 times 2, 4, 4 plus 2, 6, C2H6. All right. Then propane, N is equal to 3. Okay, now I want you all to find out the molecular formula for propane and also for butane. Butane, N is equal to 4. Okay, good. I see a few answers. So molecular formula for propane is C3H8. And for butane, it is C4H10. Okay. All right. So for propane, it will be 2 times 3, 6, 6 plus 2, 8. Okay. Butane, 2 times 4, 8, 8 plus 2, 10. So these are the molecular formula. So once you know the number of carbon atoms, you will be able to find the molecular formula for any alkane. And also, let us look at this part here. Earlier, we learned that one of the characteristics of the homologous series is that the neighboring molecules differ by a CH2 group. So this is CH4, C2H6, C3H8, C4H10. So you can see that there's the next one increases by 1 carbon atom, and the hydrogen every time increases by 2 carbon atoms, CH2. Okay, so this is so what we learned just now, that's correct. Yeah, each member differs by a CH2 group. Okay, so now I do have a question for you. Now I want you to find out the molecular formula of an alkane with 11 carbon atoms. Okay, what's the molecular formula of an alkane with 11 carbon atoms? Okay, so use the formula CnH2n plus 2. So that would be C11H 2 times 11, 22, 22 plus 2, 24. C11H24. Okay, so as you can see here, the molecular formula of an alkane with 11 carbon atom is C11H24. Okay, so once you know the general formula of a particular homologous series, it will be very easy for you to write down the molecular formula. Okay, and once you know molecular formula, drawing the structural formula will be easy. You will not make that many mistakes. Is that clear? All right. So the first step to draw the correct structural formula is from the molecular formula. Okay. All right. I have another question as well. Okay. Listen carefully, students. C15H32 is the molecular formula of an alkane. What is the molecular formula of the next member in the series? What is the molecular formula of the next alkane? Okay, good. It's C16H34. All right. So you can use the general formula because it already says it's an alkane. So the general formula would be, you can use a general formula would be and find the formula. Or we also know that the neighboring member differs by a CH2 group. So C15, so this is C16, and then 32 plus 2, 34. All right. So these are some of the types of questions that you will be asked for the molecular formula of regarding the molecular formula and general formula of alkanes. Right. So as you can see, the molecular formula that we calculated just now is correct. Okay, you have CH4, C2H6, C3H8, C4H10, and so on. Okay, is that clear, students? All right. So for today, we will stop here regarding the organic chemistry. So what we learned today is what is organic chemistry, what is a homologous series, what are hydrocarbons. Okay, and we learned about alkanes. We learned that alkanes saturated hydrocarbons. We learned the names of the first 10 alkanes, the general formula of alkanes, and also how to find the molecular formula of alkanes. Okay, any questions regarding the organic chemistry that we learned just now? Okay, if no questions, we'll move on to the homework that I gave for this week, that is week 7. All right. So these are the multiple choice questions. Very quickly, let's discuss the answers. Okay, question number 1. Which of these is an important source of sodium chloride? Okay, so we learned the other day that sodium chloride or brine is obtained from sea water. Obviously, it is not present in the atmosphere, and it is also not present in crude oil. Sodium chloride is present in sea water. Okay, so that's why sea water is salty. Next one, in the electrolysis of dilute sodium chloride solution, what gas is produced at the cathode? So the gas that is produced at the cathode is hydrogen. Though there are sodium ions, okay, though you have sodium ions and hydrogen ions, because it's a dilute sodium chloride solution, the sodium is not discharged because it is more reactive. The hydrogen ions are discharged, and so you get hydrogen gas. The next one, which statement describes a weak acid? The answer is D, because the definition for acid is an acid is a proton donor. Acids are proton donors. Okay, and what's a weak acid? It is an acid that partially ionizes. That means all the particles do not split into ions. Let us say if there are 1,000 particles, only 4 will split into ions. Is that clear? So obviously acids are not proton acceptors. So A and B are totally out. So it is a D because it's a proton donor and it's also partially ionized. Okay, the next one, group 1 metal. Okay, question number 4. It's about a reaction between group 1 metal and group 7 element. Okay, so you need to find the name of the compound with form that is formed between group 1 metal of highest density and group 7 metal of group 7 element of lowest density. Okay, so when you look at group 1 metals, as you go down the group, the density increases. So when compared to lithium and sodium, potassium has the highest density. All right, so that's potassium. And when you look at group 7 elements, you have chlorine, bromine, and iodine. Chlorine is a gas, bromine is a liquid, and iodine is a solid. So chlorine will have the lowest density because it's a gas. All right. Okay, so the compound that is formed between potassium and chlorine is potassium chloride. So that's why answer is B. What is the correct half equation for the cathode in the electrolysis of dilute sodium chloride solution? So earlier we saw the product that is formed at the cathode is hydrogen gas. So hydrogen, the product that is formed is hydrogen gas. So here none of this has hydrogen gas, only this has the hydrogen gas as the product. And also the half equation, the reactant part over here, the symbols are also correct. Okay, so answer is C. The next one, what is hydrogen often used for? Hydrogen is used as a fuel. Okay, so as you can see, these questions are from what you learned in the previous lessons. Okay, it's all the questions are from chapter 9. So next lesson, I will give you questions on organic chemistry. Okay, what is chlorine used for? To kill bacteria in drinking water. It is not a food additive. A food additive would be sulfur dioxide. Yeah. Okay. What is sodium hydroxide used for? To make soap, and not to make petrol or not to make plastics. When sodium chloride is electrolyzed on a large industrial scale, what is the name of the apparatus used? Remember, the chlor-alkali industry, the name of the cell is a diaphragm cell. Okay, why is it called a diaphragm cell? Because the cell is divided into 2 compartments using a diaphragm. What is the correct chemical name for the substance more commonly known as quicklime? So what is quicklime? Quicklime is calcium oxide. Okay, calcium hydroxide is lime water or slaked lime. Calcium carbonate is limestone. Okay, question number 11. What is the correct balance symbol equation for the formation of solid slaked lime? Okay, we learned that solid slaked lime is calcium hydroxide. So when you look at A, this formula is wrong. Okay, so B and C, both the reactants and products, the formula, the balancing, everything is correct. But here it says solid slaked lime. So look at the state symbol. So only in C, the state symbol is correct for calcium hydroxide. So answer is C. All right, question number 12. Question number 12 is about the thermal decomposition of copper carbonate. Okay, so when copper carbonate is thermally decomposed, you get 2 substances. So green color is for copper carbonate. A black solid is formed and a colorless gas is given up. What is the black solid? So if you know the decomposition of copper carbonate, you'll be easily able to answer this question. So copper carbonate will form copper oxide plus carbon dioxide. Okay, so the answer here is copper oxide. So sometimes in order to answer your questions, you need to write down an equation or do a little bit of a calculation. Okay, so that will help you to get the correct answer. Instead of just staring at the question, you do some working. Okay, question number 13. Calcium phosphate forms when calcium chloride and sodium phosphate solutions react together. Which values of X and Y balance the equation? Basically, here you're only going to balance equation. Yeah. All right. So let's see how you can balance the equation. You need to find out X and Y. So let's find out X. X is for calcium. All right. So on the product side, you have 6 calcium atoms. 2 times 3, 6. Okay. There's no other calcium there except for this one. So let's put 6 here. Okay. So 6 calcium, 12 chlorine, 12 chlorine. Okay. So this is balanced. And now for sodium. All right. There's no sodium here in calcium phosphate. In sodium chloride, there are 12 sodium atoms. So here it's Na3. So 3 times 4 will become 12. Okay, so 4. So phosphorus also becomes 4. Yeah, all balanced. So the answer is D, 6 and 4. Okay, so this is how you balance the equation. All right, next one. Which compound would not be used as an important part of a garden fertilizer? Okay, the answer is C. Now, why is the answer C? Here, the question is asking about the NPK fertilizer. We learned that NPK fertilizers contain nitrogen, phosphorus, and potassium. And nitrogen is important for leaf, phosphorus for roots, potassium for flowers and fruits. Okay, but they don't mention the word NPK. It's for us to know that these elements are needed for the healthy growth of plants. So if you look at calcium, in calcium there is phosphorus. In B, you have potassium nitrate, you have potassium and nitrogen. In C, you don't have any nitrogen or phosphorus or potassium. In D, you have nitrogen. Okay, so the NPK, so actually this is the idea of NPK fertilizer should be understood here. Is that clear? So that is why the answer is C, because there is no nitrogen, no phosphorus or potassium in magnesium hydroxide. Okay, question number 15. During the electrolysis of concentrated aqueous sodium chloride, chlorine gas is produced at the positive electrode. What happens at the negative electrode? Okay, so earlier we've seen that at the negative electrode, hydrogen gas is formed. Okay, so at the positive it's chlorine, at the negative it's hydrogen gas. So let's look at A or B. Product at the negative electrode is hydrogen. And what happens to the solution? Does the solution become acidic or alkaline? So if you remember, or if you have revised the chlor-alkali process, we learned that in the electrolyte, which is concentrated sodium chloride solution, you have Na plus ions and Cl minus ions from the sodium chloride. You have the H plus ions and OH minus ions from water. So the hydrogen ions form hydrogen gas. The chloride ions form chloride gas. The sodium and hydroxide ions, they become good friends and they form sodium hydroxide. And sodium hydroxide is an alkali. So the answer is B. Okay, so at the negative electrode, the product is hydrogen and the solution becomes alkaline. Okay, so well done to those who have got all the answers correct. Those who have not got all the answers correct, okay, don't lose heart. Keep revising and you'll be able to do well. Okay, so our lesson for today, we did 2 things. One is we learned organic chemistry, the introduction, and a bit about alkanes. And then we also discussed the answers for the homework, the MCQ question homework given this week. Is that clear? All right. Any questions, student, on today's lessons? Okay, if no questions, see you all next week. All right. And stay safe.